Now we have to make change for, let's say, 12 rupees, and we have 4, 5, and 6 rupee coins. So what we can try to do is we can try thinking bottom up from the smallest value. Let's say we try to build a table where what we try to find out is we find out what is the minimum coins required to make change for denomination I. Let's say if it is 0, how many coins are minimum coins are required out of these to make change of 0 rupees? So we know the answer is 0. Now if we go with 1 rupee, now what we should do is we should look at the array. We cannot choose 6, we cannot choose 5, we cannot choose 1 because 1 rupee cannot be made. So let's say we put this value as infinite. Let's go with 2. If you have to make change of 2, again the same situation, we can't choose any coin because all coins are bigger than 2. For 3 also, not possible. But for 4, if we choose, so what we will do is we'll look at the array and we'll try to see, can we choose 4 and make the sum? Can we choose 5 and make the sum? And so on. We can choose 4. Now you're making a sum of 4. You have already chosen a coin of 4 rupees. So you're left with 0 rupees. Look back at the value of 0. 0 requires 0 coins and 4 requires 1 4 coin and whatever coins required by 0. So you can fill 1 over here. Same way, if you want to make change of 5 rupees, if you choose 4 rupee coin, then what you need is you need to go back to make change for remaining 1 rupee, but 1 is infinite. So that is one possibility for 5. So with 5, you can choose 4. So you need to make change for 1 rupee and add 1 to it. That is how we will look at it. But for 5, if you choose 5, you'll be left with 0, and answer for 0 is 0. So we can fill over here 1. Same way for 6. If you choose 4, you cannot make the change. If you choose 5, you cannot make the change. If you choose 6, you can make the change and you need only 1 coin. Now, same way coming to 7. Let's say you're going with 7. If you choose 4 rupee coin, you have to look for 7 minus 4. Remaining value 3 requires infinite coins, so not possible. With 7, if you choose 5, you have to look for how many coins to make change for 2, not possible. From 7, if you subtract 6, you have to look for one's answer. One's answer is infinite, not possible. So 7 is impossible to achieve. Coming to 8. With 8, if you choose 4 rupee coin, 8 minus 4 gives you 4. So remaining 4, you already have the answer for this. That 4 rupee change can be made with 1 coin. So if 4 rupees is possible in 1, we can take 1 more coin and make 8 in 2 rupees. Same way, let's look at 8 minus 5. 3 rupees can't be made, infinite. 8 minus 6 is 2, can't be made. So these are not possible. Same way, let's go to 9. 9 minus 4 is 5. You know, the change for 5 rupees can be made with 1 coin. So 9 minus 4, 5, it will be 2. Same way, 9 minus 5 is 4. Change of 4 can also be made with 1 coin. So 1 plus 1 only. We already have a better answer. Then 9 minus 6 is 3. 3 gives us infinite, so not possible. So if we continue like this, if we continue going like this up to 12, we would get better clarity how we are building the answer. This is just kind of giving us the intuition. So 10 minus 4 will be 6. Answer for 6 is 1. So 10, the answer is 2. 10 minus 5 is 5. Answer for 5 is 1. 1 plus 1 is 2. Already good. 10 minus 7, 10 minus 6 is 4. 4's answer is 1. So for answer 10 is 2 only. Okay, coming to 11. If you're making 11, you choose 4. 11 minus 4 is 7. 7 is infinite. Don't choose that. 11 minus 5 is 6. 6 answer is 1. So 11 can be made with 2. 11 minus 6 is 5. 5's answer is 1. 1 plus 1, 2. So 11 can be made with 2 coins. Coming to 12. 12 minus 4 is 8. So just check what is the answer for 8. 8 can be made with 2 coins. So here we will say 2 plus 1, 3 as of now. But we will still explore 12 minus 5 makes 7. 7's answer is infinite, not possible. Third is 12 minus 6. 12 minus 6 gives us 6. Let's try to find out what is the number of ways to make change or minimum coins to make change. 6's answer is 1. So 1 plus 1 is 2, which is definitely better than 3. So we overwrite it. So if we try to summarize whatever we have discussed, is it fair to say that min coins of 0 can be filled directly with 0, but to fill any other value in this array, min coins of I, what we have to do is we have to subtract from I. From I, if you notice, for every index, we were subtracting every array element. From I, you have to subtract d of j. And when you subtract that, this you have to do for every j going from 0 to n minus 1. If this value is present already and not infinity, so what you will have is the answer will come from min coins of this plus 1. And we are interested in choosing the minimum value out of all of these. And of course, you should think about that. First of all, this value I minus dj should be greater than or equal to 0, and I minus d of j should not be equal to infinite. So look at this. This is the intuition with which we were going and tabulating. And this is ideally the recurrence we have for this coin change problem. And this recurrence's beauty is it uses only 1D space, and 1D space size that we need is it is target sum plus 1. You need an array of 13 size. This is the space required. And every value is being filled by looking at all the array values. So the time that this is going to take is around, the way we fill this table is it's target sum into size of this array, which is d dot length. Yeah, that would be the time to fill it, and we would have found the answer.